Today we will use SageMaker Autopilot in a case of document classification. SageMaker Autopilot is a service which automatically builds, trains, and tunes models based on data. It reduces valuable EDA and helps us save time and scale up. Today we are going to use the public dataset from UCI, where the data is related with direct marketing campaigns of Portuguese banking institution. The goal here is to predict if the client will subscribe to a long-term deposit. Let's walk through a brief hands-on demo by using the autopilot for the given case. So first thing that we need to do is we go to the AWS Management Console, and here we can search for the Amazon SageMaker module. From here, we will move on and choose the studio part. Basically, we can choose from different regions, and you can get started by configuring your own user profile for each region. Here I have created mine, so I will just continue and open the studio. This usually takes some time to redirect to our Jupyter Lab SageMaker notebook type of instance. We'll give it a few minutes. So now that we are here, basically we check and we will start by creating a notebook, which will be the demo for this session. First, what we need to do is we get the data. So basically we start by capturing, let's say, all the output which is unnecessary for this case after running the cell. And after that, we unzip and we get the data from the source that we mentioned, right? So the direct marketing campaign. And after that, we unzip it and we save it as a local file. So we can start by changing or by assigning, let's say, the notebook environment. Here we have selected a data science image and Python 3 kernel and a simple T3 medium instance type. So we select that, and after that we can just simply run this script. I will make sure to send you guys everything that you need to rerun the same script. After running that, we see that we have the data file that we need for running the model, and after that we review the data format, right? So here we can see we have 21 columns, which means that we have 20 features and one target variable, which is the conversion, whether it's the campaign has succeeded or not. We see the Y, which is the target variable here. Now in this step we would move on forward and perform some exploratory data analysis, which takes considerable time given many insights that we need to find. In this step we simply just initiate and configure the autopilot to do that for us. So first we start by starting autopilot session based for the data that we have. So we see here that we have the following URI based on the data that we have. Make sure that you save the number that you are utilizing together with your region for the instance that we are running. You will need this for later. Now, after running this cell, what we need to do is we go to the experiments. Basically, in order to configure that, you go to new, and you will create AutoML experiment. So in order to create that, let's say we will first need to assign a name. Let's say AutoML demo session. Then the ST location that we need, like basically, is the data location that we were provided by the output of the script here. We will simply just copy paste that and move on to the targets and features. Basically, we don't need to change anything else. We are auto splitting the data based on the format, and we are automatically creating an output for the data location. So we move basically to assign the target and the features. Basically, the target here is simple. It's given is the Y variable, which is a binary type, yes or no, simply whether the conversion has been made or not, and the rest are simply just target variables, are simply just features which we will use to predict the target variable. So next we move to the training method. Now we can choose one of the three here. Basically, autopilot or the automatic version simply just runs and decides which would be the best training method based on the dataset type and size that we have. Or we could choose the ensembling or the hyperparameter optimization methods, which basically do just that, basically either ensemble or like stack a multi-layer model, or pretty much tune hyperparameters running training jobs based on the dataset. For now, we will just move with auto, and then we will run by on the deployment settings. Basically, like we will auto deploy and automatically create an endpoint for our session. Let's say like AutoML demo endpoint. And simply here, like for the machine learning problem type, we will move on with auto, but we can choose binary classification as well. We could choose like regression or multi-class. Simply here in this demo session, we want to check the reliability of AutoML, and we will just do that and continue by reviewing what we have made so far. So basically, we have put the name, the input data location, auto splitting the data and automatically creating an output location, have selected the targets and the features, the training method, and basically the deployment and some advanced settings which we do not need for now. So we move on to create the experiment. Now this will take a considerable amount of time since we are running many trials to generate a report. So we will be back after, let's say, half an hour or more than that after we have completed the sessions. So after waiting for about half an hour, we can see here that we have finished the autopilot job. We have run several trials where we have found the best models based on the F1 score. Now, what we can do here is first we can go and check the exploration notebook, which basically in machine learning lifecycle would be the exploratory data analysis. Here we have a summarized report with different findings regarding the data. You can see the report contents here and basically skip to which one you find more useful, or basically check all of them. Basically you have the target analysis, see the distribution of data, data sample, whether there are any duplicate rows or different correlations, anomaly detection based on data, and pretty much anything that you might find useful and perform on your own in exploration report. However, now that we have found the best model, we're going to go ahead and deploy this model. This will open a new window, and it will ask us whether we want to make batch prediction or real-time prediction, and based on that we will configure the endpoint. For our case, we will make a real-time prediction and choose a name, let's say tutorial autopilot best model, which encapsulates pretty much what we are deploying. And we can choose the instance type here. Basically, I'm choosing the M5 2x large. That should be enough for our case. And we can choose the instance count here. We can be more than one, but for now we just need one. We can enable data capture for saving prediction or requests or responses. And we can also configure some advanced settings. This would be the case for deploying this model, where we will need to configure the IAM role, an encryption key, or perhaps a virtual private cloud. We don't need to do any of that for now, so we're just going to move on and deploy to the endpoint. Now, after deploying to the endpoint, we will see here a window which will basically later on show us different findings regarding the endpoint details. Now, in order to find the status of the deployment, basically we go to the Home tab here, and on the deployment subsection, we move on and we go to the endpoints. Now, it will take some time for us to deploy the model. We don't have any endpoints currently, but once we start deploying it, basically we will see that we will have enabled an endpoint basically creation based on the tasks that we made. So here you can see 39 seconds ago we configured basically the endpoint here, and we can wait for about 10 minutes. That's how long it takes for us to configure the endpoint. After that, we'll move on to create a prediction built on that endpoint. So after waiting for a few minutes for the endpoint to be configured, now we can see the status, which means that the endpoint is currently a service, and we can build a prediction on top of this endpoint. So we can go to the notebook instance that we initiated, and here we have a new script where we have configured basically the endpoint and the model which we are going to build on top of this, so we can create a prediction for on top of this endpoint. Basically, we enter the name of our endpoint, we initiate a runtime session, and then we pre-configured the we can see here TN, TP, FN, and FP. Basically, they stand for true negative, true positive, basically the elements of the confusion matrix, which we are then going to combine in the formulas, specifically for the accuracy, precision, recall, and F1 to get a better overview of our predictions. And then we are simply just going to print that out. So simply we just run this cell, and after that we are going to wait for a few minutes, and basically we'll see a progress bar which will show us the predictions for the first 2000 sample rows. So let's give it a few minutes and we'll come back to it. So after waiting for a few minutes, we have seen that we have finished running the prediction. Basically on 2000 samples we have the following accuracy KPIs. Basically an accuracy of 0.9798 approximately, precision of 0.45, a recall of 0.59 or 0.6, and an F1 score of 0.51 or like 0.52. Basically, after finishing this tutorial, make sure you delete the endpoint and delete all the saved instances from saving you any recurring costs. So the key takeaways from our sessions are the following. We can use Autopilot to save exploratory data analysis time, develop a comprehensive report, especially for sensitive type of data, and develop an easy to maintain, scalable ML pipeline.